So from our last lecture on radius vector, we learned that any point can be represented by a vector called as the radius vector r, and the modulus of r, which is called as the length of radius vector, gives us the distance of the point from the origin. Agreed? Now we'll continue our discussion on center of mass. Now consider you have a rod. Okay, so consider this is a rod, and say this rod has a mass m. Okay, and say length of the rod is l. Now can you tell me, can you find me one point on the rod where I can balance the rod on a needle point? Yes, that point is exactly at the center. So here, if I can put my fingers, that is exactly at length l by 2, then I can balance the entire rod. The reason I can balance the entire rod, because at the center of the rod I can carry the entire mass of the rod, or in other words I can say that the somehow the entire mass of the rod is concentrated at the center, and as a result of which I can actually balance the entire rod just by holding it using my fingers at length l by 2. So this length l by 2 is called the center of mass of rod. Center of mass in shortcut is COM. So the center of mass of rod is at a distance l by 2. And you see an interesting thing, that the center of mass of the rod is on the rod. Now consider a ring. So consider this is a ring, and on this ring, say this is a ring of mass m. Okay, and now can you tell me at what point on the ring, if I put my finger, I can balance the ring? The answer is the point does not lie on the ring, but the point lies at the center of the ring. Okay, now you would say, if this is a ring, now to balance the ring I need to balance the ring by holding the ring at the center. But the question is, the center is empty, how can I balance the ring? The idea is, if you join this ring with massless thin okay, so join it by using massless thin spikes or spokes, you can say, like in the bicycle, or you can say massless objects. Then now if you have this, and now you put your finger at the center, that is at point O that I said at the center of the ring, you can balance the entire ring. So amazingly, the center of mass of the ring, I mean the place where the entire mass of the ring is concentrated, is in the center of the ring. And the center of the ring is not on the ring, but somewhere outside the ring. That is, the center of mass of ring is outside the ring. Interesting, right? Because you cannot balance the ring anywhere by holding the ring only. Okay, only when you just attach small massless threads from the center to the ring, and now when you keep your finger at the center, you can balance the entire ring. Let me give you an example. Have you seen bicycle tires? Doesn't it look like bicycle tire with spokes from the arising from the center? Okay, and then you can balance the entire bicycle rod by just keeping your fingers at the center. Okay, here you can balance the entire um, ring. So what you understand? So in case number 1, the center of mass of the rod lied on the rod. In case number 2, the center of mass of the ring lied outside the ring. Okay, so what do you mean by center of mass? So unofficially, center of mass is a point on the substance or outside the substance where the entire mass of that object is supposed to be concentrated. See why I said supposed to be concentrated? Because when I said the entire mass of the rod is concentrated at L by 2, is it true? It's not true, because the entire mass is distributed along the length L. How can I just say that the entire mass is supported at L by 2? It's not true. But hypothetically, somehow this length L by 2 is behaving as if the entire mass is concentrated at the center, because I can balance the entire rod by just using my fingers at L by 2. So center of mass, either you explain it or think of it as the place where the entire mass has got concentrated, or you can think center of mass as the place at which you can actually balance the entire system. Agreed? So let us look one more example. Okay. So let us look at third example. In the third example, consider you have two masses, two balls. This is ball of mass m, and this is another ball of mass m. Agreed? And consider these two balls are attached by a massless rod. What is that? A massless rod. Now, can you intuitively guess the position? Okay, if this is the length L, so the total length of the rod is L. So can you guess intuitively the position where I can balance this system? So what is this system? This system has two balls of equal mass m, and they connected to each other by a massless rod. So intuitively the entire mass of the two ball is concentrated at the center, that is at L by 2, because at L by 2 if I put my fingers, I can balance this system. So center of mass is all about the finding the position at where I can balance the entire system. I can say in that way. Or there is another definition: center of mass is a place where the entire mass is supposed to be concentrated. Now, why do I say the entire mass is supposed to be concentrated? The reason is, in case number 1, if I put my fingers at the center of the rod, then I can feel the entire weight of the rod at the center. In case number 2, if I put my fingers at the center of the ring, okay, such that massless spokes have connected the ring, then I can feel the entire weight of the ring at the center. Similarly, in the third case, if I put my finger somewhere around the center, then I can feel the entire mass. What is the total mass? The total mass of this system is 2m. Then at the center, I can feel the entire 2m mass on my fingers. That's why another definition of center of mass is said to be the point where the mass of the system is entirely concentrated, because at that point if I try to balance, I am not only balancing the item, but I am also feeling the entire mass, or I am also carrying the entire mass just by touching that point. Amazing, right? So this is what center of mass actually is. Agreed? Now the question is, we understood logically by looking at case 3, 2 and 1 what center of mass is. Now case 1, 2 and 3 was very easy, and they were so intuitive that we can guess the points where the center of mass lies. But question is, if I ask you, so consider so this is the x-axis, okay, and say on the x-axis there are two balls. One ball is at a distance 4 centimeter from origin, and another ball is at a distance 6 centimeter from the origin. Now if I ask you, the mass of ball 1 and ball 2 are same, so this is of mass m, this is of mass m, and if I ask you at what point you can balance this object, you can easily find it by saying that I can balance somewhere in between. By between I mean at a distance 5 centimeter from the origin. Am I correct? Yes. But now if I ask you, what if ball 1 were heavier than ball 2? I mean the mass of ball 1 was greater than mass of ball 2. then can you tell me the point where I can feel the entire mass of the system? Now this system is a bit weird. Why the system is weird? Because the masses are unequal. So if the masses are unequal and if I hold at the center, then the problem is the rod will fall because there is more weight on the left hand side. So somehow I need to shift my center of mass from the center to this point. And amazingly, if you balance this system of unequal mass at this point, the entire system will be balanced. Agreed? So logically we understood that we need to shift the center of mass from the center. Okay, let this shift be delta x. Now question is, can we mathematically find the value? So see, these are all logic. Till now, whatever I was doing, I was just doing logic. Now I want to ask you, is there a mathematical technique where if I give the information of mass m1, mass m2, and where they are present, then that mathematical formula will automatically give me the position of center of mass? Okay, so I want to develop a mathematics for the center of mass. So in the next lecture, we'll develop a mathematics for the center of mass such that given the mathematical information of the mass of the system and position of the system, I can easily derive mathematically the point where the entire mass is concentrated without using too much logic. That we'll do in the next lecture.